see some hairless rats. This was part of a polonium-210 metabolic study. And one of the things that came out of this is there is another excretion pathway for polonium beyond urine and feces, well, and even sweat. Anybody want to hazard a guess? And those of you that heard me talk yesterday don't speak. Anybody want to hazard a guess what the other pathway is? Can't say anything. It's a volatile substance of some sort that comes out either in breath or more likely in flatulence. And it is small, but it is a pathway. This is one of our mass spec units. We have 3 that are available to us of different configurations. This is some of the in vivo stuff that goes out into the field. You'll see that we test them under all conditions. Down here, that's me standing between the 3 portals at a facility near us in a snowstorm. We tested this and a mini-century at the same time. And it was about -5 degrees when this was done. And I can tell you anything with an LCD screen does not work well in these temperatures. You need to be inside. This is a search and identify hyperpure germanium that is electrically cooled. But when you couple it to a laptop, it becomes a spectroscopic system. So we extended its use from the original design into our portable whole body counter of which we now have 4. This is the original portable whole body counter that was actually used up in the Northwest Territories when we were looking for cesium and the indigenous population up there following Chernobyl. And that's a whole story in itself, but I'll get right to the chase on that one. We found radioactivity up in the Northwest Territories, and we found the bulk of the radioactivity that was in the Northwest Territories was from the A-bomb tests in the 60s. It persisted a long time. Here's some equipment in the bioassay lab, and I'm just going to whisk by this because I want to get to one of the last slides. Some of our phantoms that we use. This is our phantom family down here, our 4-year-old, our 10-year-old, our reference female, our reference male, me, somewhat younger. This is our 95th percentile. This is a sliced phantom whereby the source is a solid. This is a virtual series that we use for Monte Carlo calculations. This is a view of one of the lung phantoms, the de facto standard. There are problems with this, which is exemplified by the picture down here. The yellow circles are where the detectors sit. What's the problem with that picture? Well, this particular one down here, which is over the left lung, where the heart is, sees very little of that lung. That's partly because of the design problem with this phantom, which is a story in itself, and I don't have time to tell you. Anyway, on the right here, we redesigned it somewhat. It still doesn't solve the problem, but it can improve things. This work of art is the Japanese Atomic Energy Research Institute phantom, and you'll see that it is extremely detailed. The lung shape is much better in this phantom. There are differences in using this as opposed to the Lawrence Livermore one. The detail in this on the back is beautiful. You see the spine and the ribs and the shoulder blades, none of which exist in this phantom, by the way. And in the cover plate you can see the difference here between the wood and the cartilage. Beautifully made. There are, to my knowledge, only 4 of these in existence. We've got one, the IAE's got one, and there are 2 institutes in Japan that have one. When I tell you it's about 2 million yen to buy, you'll understand why there's not too many of them. When we bought it, it was $100,000. This is some phantom work that we've done in the past. On the left is a commercial phantom. The activity is distributed in the bone. It's an artificially done one. And on the right, it's a historical deposition of real bone. It's part of the gun phantom from USTUR. And when you compare these 2 phantoms together, you get very, very different results. And that's the subject of one of the papers that we published recently. Our thyroid phantom This is the biggest performance test program that we have. There are about 150 facilities, so I have one staff member looking after that year-round. And this is a sampling of some of the publications that we have issued recently. My personal total is at 188 right now. I wanted to just highlight a couple of these. So, through interesting collaborations, I find myself on a crown ether study where they're using magnetic particles with crown ether attached to it. So you put it into the sample, the crown ether sucks up strontium-90, and then using magnets, you take out that crown ether that's now got the strontium-90 in it, you take it somewhere else, so you've got the strontium-90 separated from what was there by magnetic separation. A nice piece of work, that one. This one here, these are both using magnetic cation separation. This was part of an international workshop that was set up recently by one of my colleagues, Sunshine Lee, and we had a number of people from all over the world come in. We need to try and identify gaps, areas for development. That forms part of a special issue, actually, of health physics. This is the two-leg study that I talked about. That was interesting in as much that it was a multi-country collaboration between the USA, Canada, Spain, France, and Germany. And part of that study, actually, it was the French who identified that the activity in the USTOL gun phantom was in fact incorrect. And when USTOL went back to the original record, they found that the radiochemical work that had been published in the single issue of Health Physics was in fact not right. And this particular paper has the reevaluation of what we think is in the leg. And I say what we think was in the leg because the way that was done was essentially half of the phantom was radiochemically analyzed and the other half was encased in tissue equivalent material. And then we make this leap of faith that whatever was in the right side of the phantom and whatever section was analyzed was also in the other side. And we don't know if that's true or not. I'm just about out of time, so